True or false? The ratio of the areas of two similar triangles is equal to the ratio of their corresponding sides. Now that is false. Why? It is equal to the squares of their corresponding sides. We have seen this earlier also, but I'll just prove it. It takes hardly half a minute. See these two triangles ABC and PQR. They are similar to each other. Similar means what? The angles of each angle is corresponding angles are congruent, right? And the ratios of the sides are equal. Okay. So area of triangle ABC is what? Half base height, half into BC into AM. Similarly for PQR also half QR PN. Okay, half of gone. So what remains? BC into AM upon QR into PN, right? BC into AM upon QR into PN. Now we have to find the relationships. See this. What is this? BC upon QR. BC upon QR. How to find this relationship? Now these two triangles are congruent, ABC and PQR. So BC upon QR will be equal to AB upon PQ, right? Because ratio of the corresponding sides. So here we can write AB upon PQ now. Now about AM and PN, right? Okay. Now consider the two triangles ABM and PQN. ABM and PQN. Okay. What happens in that? These two angles are congruent, B and Q, because ABC is similar to PQR, therefore corresponding angles are congruent, and angle M is congruent to N. Why? 90 degrees both. So ABM similar to PQN by what? AA test, right? Now when these two are similar, then the ratio of the sides will also be equal. Therefore AB upon PQ will be equal to AM upon PN, right? That's what we want. So instead of AM upon PN, write there AB upon PQ. So what happens now? Here also AB upon PQ. Here also AB upon PQ. That is equals to AB upon PQ the whole square. That's what our statement is. Next, if a line is drawn parallel to one side of a triangle to intersect the other two sides or in distinct points, then the other two sides are divided in the same ratio. So that is right. Here PQ is parallel to BC, that is drawn. Now what is given? Now AP upon PB, AP upon PB will be equal to AQ upon QC. Why? Similarity of triangles, and that's what is asked. Then the other two sides are divided in